So one of you asked me about the limit of CER. Okay. So here, if you want, we have some recommendations, but there is a flexibility with acceptable values. Okay. So in general, for example, if you have a very short, if you are studying a project, for example, over 5 years, you can say I can accept CER, let's say below 30% because the lifetime is really small. But as the lifetime will increase, you need to be on the safe side. You need to increase your expectation and set a higher limit for CER. Okay, some maybe some businessman can say even 30% for me for 20 years is low. So you can increase your limit. You can say I will go with this project for a CR of 50%. Okay. So it's really a subjective decision. But in general, one of the recommendations is at least 30%, especially for long periods of time. Okay.
Okay.
Okay. So now for the second price, for a selling price of $4.2 per item. So the only parameters that will change here is, as we said, the income per year. So the income per year now can be calculated as 1,000 times 4.2. So we just have to replace 4,000 by 4,200. And if we, of course, when we do this, we expect to get a larger NPV because all other parameters are fixed. We just increase the income. And if we do our calculation, we can find out that actually we have an increase in the NPV to reach a value of $6,855.26. So if we calculate the new CER, it's much better. And this variation in price, okay, which is around it's 5% increase. Okay. So which is acceptable. It's not a very big increase of price. So since a small price increase will really lead to a significant increase in the CER, this is a possible strategy to go over in order to say if I use this price, I am in a better condition, so I can invest in this project. In case I am putting a limit for me to have a minimum CER of 30%, I can go with this price. Okay. So this is for project A. Now we can ask several types of questions here. Okay. If I ask you, for example, calculate the life cycle cost of project A, the LCC. How you can calculate it? What should you change in this formula? If I ask you to calculate the life cycle cost.
We add the initial investment to the maintenance cost.
Okay. Here, if you want, if I want to
It's
change the
I
formula, okay, what will change? I put plus I,
plus I.
okay. I remove the income, okay. I put plus summation from 1 to 8 of cost over 1 plus I to the power L. And here, what do I do for the salvage value? It's plus or minus?
I subtracted.
I subtracted, okay, because it's an income, because I consider that it's like an income for me. At the end of lifetime, I can sell my equipment, okay. So this is how, if they ask you for the life cycle cost of your system, you just have to say this. So it's plus I plus summation from 1 to 8 of cost over 1 plus I to the power L minus salvage value at year 8. Always when they ask about the life cycle cost, it's at the end of lifetime. Okay. While for NPV, I can ask you for the net present value at any year. But here, because I asked you for the CER, whenever they tell you calculate the CER, you need to use the NPV at end of lifetime. But if they ask you about the payback period, you need NPV, but of course not at end of lifetime. Okay. So this is about the first question. Let us move to the second one. So here, if they ask you to comment on your results, okay, in general, they will ask you to do interpretation of your results. So what we can say, we can conclude that if we consider the project to be profitable for a CER of 30%, a selling price of $4 per item will not be acceptable, while a price of $4.2 per item is acceptable. And if we want to add another comment, as we discussed before, whenever we do economic or financial analysis, it's very important to consider sensitivity analysis in order to determine in which conditions the project will be profitable. So here, for example, we studied, here we just considered two cases, but actually when they do an analysis, they consider the whole range of possible selling prices, plus they consider different discount rates, because when you vary the discount rate, it's like you are trying to tackle different range of investors, because each investor will give a value for A. The discount rate is affected, if you want, by the investor, as we have seen in the course material, because to calculate A, you need to consider, for example, the percentage of debit. We'll see this again in the coming chapter. So it depends. If you are using your own money, you consider then the rate of the market. If you are using loans from bank, you should consider the interest rate that they ask you for, etc. So the value of A is depending actually on the investor. And if you want to know what is the range of investors we can tackle, the internal rate of return will give us an idea, because when you calculate the internal rate of return, okay, it's the maximum value of A for which you don't lose money. Of course, you don't want to reach the IRR. It's never acceptable to have a discount rate equal to IRR, because you will not gain anything. But it will give you at least the maximum limit. So if you are below it, you can be on the safe side. So higher IRR, you have a higher range of discount rates to work with. And if you want to know exactly what is the limit of discount rates, okay, you can set in the equation, instead of finding the IRR, you can say I impose a certain CER. And for example, if I tell you I want a CER of 40%, what is the maximum discount rate allowable? Okay, we'll add this question. We can then write an equation. Instead of putting NPV equal to 0, we put NPV equal to CER times investment, and we solve for the maximum rate of return, discount rate that will allow us to consider the project to be profitable. We'll do it in a while, this question. Okay?
Professor, I have a question.
Yes.
The sensitivity analysis,
Yes.
what are the possible conditions to take into consideration?
Yes, in the sensitivity analysis, you vary all parameters. So here you have several parameters affecting your selection. Okay, you have the initial investment. And if, for example, sometimes you can find the same characteristics of a machine, but depending maybe on the source of the machine, if it's manufactured in China or in US or in Europe, you will have a range of prices. Okay, and they can vary really in a lot, with same performance nearly. So you can try to, if you do some research, you can find what are the possible capital costs that I can use for the same characteristics. So you can vary the initial investment. Concerning the maintenance, of course, it will depend on the machine. So you cannot play a lot with it. You can play with the income. So the selling price is another parameter that you can change. Okay. Also, as we said, you have a range of investors that you can tackle. So when you vary the discount rate A, you can, for example, if I tell you A 5%, maybe you will say my project is profitable. While if you consider a value of 10%, it will not be profitable. So you can say I can suggest this project for investor with discount rates smaller than this limit. Okay, so it's good also to vary the discount rate in order to know what are the investors that can be interested in your proposed project. Okay, so mainly These are the main parameters that you can vary. Okay. And sometimes, of course, sometimes you can put a plan for the selling price. And let's say you don't fix it. You don't say it's a fixed value. And they do this a lot. For example, in renewable energy project, let's say you are building a solar system, okay? And the government want to impose, for the first year, they can impose a large price. And they say we'll reduce the price with years, okay? And you can put like a plan of income in a way to enhance the condition of your project. And they do this a lot in developed countries. Whenever the government is investing in renewable energy, they can force people to, let's say, to buy electricity from them. They can put a plan, for the first year you can pay this amount, and they reduce this amount with time. Okay, so they use first a larger price to be able to enhance the the financial state or economic state of the project, and with years they can reduce the price. So you can play with a lot of parameters here in order to decide what is the better scenario, what is the best scenario to be used. Okay.
Okay, thank you.
Well. Okay, now we'll move to project B. Okay, so considering a discount rate of 5% for a selling price of $4 per item, calculate first the CER of project B and then the internal rate of return for both projects and comment on your results. Okay, so now we'll repeat the same procedure first for B to calculate the CER. So just what will vary are the inputs. Okay, and from the given, if you go back to our given, we have for machine B, the initial investment is $5,000, initial cost of 5,000. So I is equal to 5,000. We have operational cost. We have to pay $2,000 per year. So here it's not zero. We need to consider operational cost per year. Okay. And concerning maintenance cost, it's 2% of the initial investment. So 2% times 5,000, it's $100. Okay. And we have also concerning the salvage value, it's a 300, and the lifetime is the same. It's 8 years. So now we can replace into our equation. So minus 5,000 plus. Now the number of items is lower because the machine, because it has a lower cost. It has different characteristics. It can produce a lower amount, okay, and it has operational cost. So we have differences between the two machines, and we want to select what is the best between the two. So we have 800 items and $4 per item, so 3,200. And here, this is the operational cost minus 2,000 and minus the maintenance cost. And this is the salvage value. So plus salvage value, which is 300 over, and of course, we don't forget to divide it by 1.05 to the power 8 because this salvage value, we get it at end of lifetime. So we should, when we calculate its net present value, we should discount it back to present. So we divide by 1.05 to the power 8, which is the lifetime of the system. Now, if you compare just the NPV, you should pay attention. We cannot just compare the NPV value. We should compare the CER because always we need to normalize things. Okay, if I just tell you in the previous project, it's true that I gained more. I gained nearly 5,000 and after $6,000, which is larger than this amount. It's true, but don't forget that here you just invested with $5,000, while in case of A, you invested with $20,000. So you cannot base the comparison on NPV only. You should take the normalized value, and the normalized value of NPV is CER, which is NPV at end of lifetime over the initial investment. And you have 46%, which is much better than case of project A. So of course, from CER analysis, machine B is much better. Okay. Now, in case you obtained very close values, you can investigate more. Yani you can try to go in deeper analysis, vary more parameters. Plus, also don't forget, in general, we don't base our decision only on economic factors. We build a decision matrix considering several aspects: environmental, social, etc. Okay. So we need to consider factors from all points of view in order to make a good decision. So here in this problem, we just focus on the comparison based on economic factors. But actually, when we do the whole analysis, we build a decision matrix. We consider environmental effect, social effect, economic effects, and then we come up with a final decision. So in general, the final decision is not based on or decision matrix alone or economic analysis alone. You can take it after considering deep analysis from all points of view that are affecting your project. Now, okay, so for the CER, it's much better. Let us calculate now the internal rate of return. They asked us to compare the internal rate of return for both projects. And we can expect yani, to have a higher IRR for B, but let us make sure of this, because as I told you, sometimes in case you have, let's say, variation in income with years, this might affect the value of IRR, or if you change the lifetime of the project. So if you have a longer period, for example, this can be in favor of project A, because for project A you have better productivity, but the number of years, if you want, is not enough to give you the desired CER. Okay, so maybe if you have larger production and longer period, A might be a better choice. So to judge, we need to calculate the values now of internal rate of return. Okay. So now let us compare the internal rate of return for both machines. To start with, we need to put the formula. Okay. You know that by definition, the IRR is the discount rate for which the NPV will be equal to 0 at the end of lifetime. And as we discussed before, we never want to reach, the discount rate cannot reach the IRR, because if the discount rate is equal to the IRR, then we have no profit at all. Yani at the end of lifetime, I didn't lose anything, but I didn't gain anything also. And this is very bad. Okay. But what is the importance of the IRR? It will give, if you want, an idea about the range. Higher IRR means I have a large range of discount rate I can work with. Okay. And now I can add here a question. So I can tell you, instead of calculating the IRR, I can tell you, for example, calculate the maximum discount rate. So what is the maximum discount rate, for example, to have a CER equal to 30%? We can ask the question in this way. If I ask this, okay, what will change is what? Who can tell me? What will change in my formula if I say what is the maximum discount rate for which the CER will not be below 30%?
And the NPV over I equal 0.3.
Exactly.
So NPV
Exactly. And here I don't put NPV equals 0. What will just change is that NPV is equal to CER times investment. Okay. So if I impose a CER of 30%, then I can say that in my equation, instead of putting, and then I don't find the IRR, I will be finding the maximum discount rate to not have a CER below 30%. Okay. So I just put here 0.3 times the initial investment, which is 20,000 for machine A. Okay. So when I ask you this, you can exactly know what is the discount rate, what is the maximum possible discount rate. But the IRR will give you a value larger than A max because you consider NPV 0. But the importance of it, why it's an important parameter, because whenever it's very high, the range of discount rates is large that you can work with. Okay. So now you have the formula already developed before, but now what is unknown is your discount rate. Okay, you want to find what is the discount rate for which NPV is equal to 0. So we have the previous equation exactly the same, but now we don't replace I by 5%. It's unknown. Okay, so this is our equation. And using the geometric expansion, we can replace the summation by 1 plus I to the power 8 minus 1 over I times 1 plus I to the power 8. Now here you have several ways to solve. You can put this equation in your calculator and put shift solve. It will give you the answer. You can do this. Or also you can use iterative technique. Okay, so you try, for example, you say if the discount rate is